I've been getting quite a few questions on beginner 3D modelers to explain how you actually go about using a software modeling tool to model a component or a system and get it ready for 3D printing. Now, I've used OpenScad. A lot of the 3D printing people around would really always recommend OpenScad to beginner 3D modelers or 3D printers. But I find most people come back and saying that it's a fairly daunting thing to get your head around the first time, which I must agree with. When I initially opened OpenScad, I didn't really have a clue what to do, and I reverted back to things like Trimble SketchUp, ex-Google application, and I still use SketchUp, and I think it's quite important to understand when each of these tools are good. I know there's some people that swear by OpenScad, and you can do absolutely everything in OpenScad. I believe that OpenScad is fantastic for component modeling, but once you get to system modeling, OpenScad gets a bit much. I've, for instance, modeled my whole 3D printer in SketchUp because I built it from scratch, so I wanted to make sure that all the parts fit and everything fit together way before I started buying parts and getting things printed and that kind of thing. But then when you get down to the component level, to the individual pulleys and brackets and that kind of thing, OpenScad is really good for that. However, again, there's no reason why you can't do that in SketchUp. The difference, I think, has a lot to do with the fact that SketchUp is built to be as a visualizing tool, while OpenScad is built predominantly to be a 3D modeling tool. So it's a little easier to get things printable in OpenScad, but it's not impossible in SketchUp. So to get us going, I thought I would create something that all of us might find useful and that we can use, and you can follow along, see how it works, and I'll sort of introduce you to OpenScad. And the plan is to make this into a bit of a series, and I'll take you through SketchUp as well. Based on this initial session, I'd like some feedback from you guys. Tell me whether you want me to get more into SketchUp, more into OpenScad, what aspects you want me to cover. Bearing in mind that I'm by no means an expert in this. I've played with OpenScad for a couple of months, but I'm learning as we go as well. So ideally, this would be a learning experience for all of us. And who knows, we might get, all of us would gain by going through this session. So one of the things that someone proposed to me was to build a 90-degree bracket that you would use to hold, let's say, two pieces of extruded aluminium together, or anything else you might want to hold at 90 degrees. So this is those default brackets that you have a 90-degree, two 90-degree surfaces with a potential 45-degree surface that just braces the two sides together with some holes for screws to go through, and then we'll get through to make it look a little better. So one thing with OpenScad that's very, very useful for me, that almost makes it the ideal tool, is the fact that you can parameterize your work. So what that means is you can specify a couple of parameters up front, and if you then build your tool based on those parameters as opposed to hard-coded values, you could very easily vary the size and the design of your model after you've done all the hard work to make it all fit in. So to that end, I think let's start with, if we had to make this bracket, we can assume that the two sides that are attached to the piece you want to hold at 90 degrees would be the same length. So let's start with creating a variable called height width, and let's make that equal to 40. So maybe this is a good time to mention that in OpenScad you don't have units in terms of normal metric units, millimeters, inches, whatever. You only have units. However, in most of your slicer software, you will specify a unit to be a millimeter or whatever you require. So we're going with units. So we'll say that height width is 40. The depth of the piece is going to be 20. So this represents a bracket that is 40 millimeters by 40 millimeters, and it'll be 20 millimeters wide. So you'll be able to attach two longer pieces of, say, 20 millimeter extruded aluminum together. And then we'll specify a hole radius of 3, and we'll get going. So the easiest way to do that now is to start with a cube. So we'll go with the cube, and the cube is quite easy. You specify cube, and in OpenScad, all your coordinates go in little square brackets, and you can specify whether it is centered or not. I'll show you what the difference is with that now. So if we start with that, let's specify our cube to be, so the first coordinate is always x, then y, then z. So if we have a look at our little key over here, you can actually see that HW will make it 40 millimeters in that direction. If we specify in the y coordinate it to be D, it'll be 20 millimeters deep, and the thickness will be the Z axis, and you'll get that. So if I press F5 now, we should have a square or a little rectangle. So you notice what center does. So center equals true, places it in center, so it is centered on all axes that you can see. Right? If we make that false and press F5, you can see what happens. I like to build all my things centered or center justified, because then you have a defined starting point to go from. So in this example, we will have 3 rectangles we want to work with. So let's make 3 copies. And the difference being then, well, actually we want them to be exactly the same size. The difference now becomes, how do we want to rotate these guys, right? So our first cube, we'd want to leave alone. Our second cube, we would want to rotate. Right, so now the way OpenScad works is it's very much like sort of any coding language, where if you want this method to take effect on this object, you enclose it in the curly braces, right? So everything is hierarchical like that. So again, rotate takes a coordinate, a three parameter coordinate. So all our coordinates, as we said, go into square brackets, and we'll say that we want to rotate this one, the x-axis. So again, if we have a look here, we do not want to rotate it in that direction. No. So we set that to 0. We do want to rotate it on the y direction because we want it to stand up. And again, we don't want to do anything with the z-axis. So we'll have 90 degrees and 0 for that one. Let's press F5 and see what that looks like. Right, so we've got that. The third one we want to do the same with. Again, rotate curly, square brackets, curly braces. Good practice to indent that, just to make it slightly more readable. Close the braces. And this one, we want to rotate on the same axis, but we want to rotate it 45 degrees. So 0, F5, and then we've got our little rectangles. So if we want, now what we're going to do is we obviously don't want them to all cross in the center. We want to now move these guys in the right in the right place. Okay, so let's take our first one. I'm going to translate. So translate is Open SketchUp language for move. Okay, so again, 3-coordinate system, use a square bracket. So now, in this case, we want to make use, so instead of saying we want to simply translate it by 20, so if we wanted to move this guy to center there, we don't want to just move it by 20, because as soon as we change the size of our parameters, it's going to get screwed up. So what we want to do there is we want to say, let's translate it in the X direction, right, by the size divided by 2. Okay, so we press F5 now. Oh, sorry, we need the other 3 coordinates, right? So let's put 0, 0, and oh, sorry. Okay, so there's an example of a screw up. So I put the round brackets because you're doing a bit of math. So you just need to get those right. So if we zoom out here a little bit, so by the way, that zooming is your mouse wheel, rotating is your left mouse button, and panning is your right mouse button, right? So you can see there that we've moved it now all the way that way. So let's do the same with our 90-degree guy. So let's say translate curly braces. Little trick, if you highlight a couple, Control I indents the whole everything you've highlighted, right? So this guy we want to do the same with, but we want to move him in the Z direction. So again, we're going to go 0, 0, X, Y, and this one we want to now move in HW divided by 2. So, and off we go. Right. So let's leave. Let's just for a moment comment that out. So by the way, comment again, highlight a couple of lines, press Control D. If we press F5 now and we zoom in to this point there, you'll see that this is obviously because we've taken the whole height width measurement, we moved it by that. So what we actually want to do is come back by half the thickness, right? So the way we'll do that is to say height width divided by 2 is fine, but we want to minus half of thickness. So T divided by 2, F5. What did we do wrong? And we want to do the same here, minus T divided by 2. Oh, sorry. We have not specified a thickness variable, which I think is the yes. Okay. So sorry. Let's specify T equals 6. In my experience, I've seen that for 3D printing, you probably don't want to go any less than you probably don't want to go with parts less than 3 millimeters thick, because then it gets really, really thin. So to give you an idea, this part is part of my printer, and these walls are all 3 millimeters thick. Now, this was obviously the first thing I ever modeled, and incidentally worked out quite well, but given what I know now, I wouldn't go with any parts thinner than that if it is printed on a 3D printer. And I must say that you need to print in fairly high quality for that to work well. Generally, you'd want to make your parts a little thicker. So if we change this to 6, for instance, you just get a slightly more chunky part, right? So all of that still works. All of that still works perfectly fine. So now let's get back to our 45-degree angle. Let's get this guy zoomed up out a little bit so we can see what's happening. So now let's take our comments off. Now again, if you want to uncomment, just Control-Shift-D. Same thing with outdenting your stuff is Control-Shift-I instead of Control-I. So if we look at this guy now, we can see that he's back. Now we want to position him in the correct place. So when I had a look at this, I thought, wow, how are we going to do that? So I opened a browser and had a look at triangles, right? Because I couldn't remember what happened at school. So let's go ahead and do that. Okay, so in Google, what we'll do is we'll look for 45-degree triangles, right? And I found, basic triangles. Let's have a look at what they do. And we can see that for a 45-degree triangle, we can work out for the height and width will always be the same. So for that to be 1, the length of this guy needs to be 2 times, or the square of 2 if these are 1, right? So what does that mean for us? We know what the length of this side will be, so we need to pretty much figure out how far to position the thing in the X and how far to position it in the Z direction on our diagram. So the nice thing with OpenScad is you can do a bit of math. So first, let's put our translate method in there. Get that nicely indented out. And again, square brackets for our coordinate system and 3 parts. And what we'll do now is we'll position that guy in the right place. So the first thing we need to do is in our X direction, we need to move that guy by the height width divided by 2 times the square root of 2. Okay. And if we do that, okay, and let's do zeros for now. If we do that, we're getting placed way over there. And we'll have to do, we'll want to do the same thing for our Z parameter. So again, let's do height width divided by 2 times the square root of 2. And we'll see it's not quite in the right place. So what we do then, because that's about double what we need, we can divide by 2 and divide by 2. I like just tying up my brackets to be absolutely sure we're applying the right thing to the right place. And there we go. So what we can see now is that we have a nice 45-degree strong bracket happening there. It is parameterized, so if I now suddenly want to make this thing 80 long, I change that variable, press F5, and there's our bigger bracket. I go back to 40, and I might want to make it 40 in that direction. It all keeps working, right? So that's the power of the parameterization of your model. So remember to save often, and let's call this bracket dot. or just bracket, and I'll put the SCAD bit on itself. Okay, so there we have the starting point of our of drawing a model in OpenScad. I think I'm going to call it quits there, and we'll carry on with this next time.